Okay, welcome to another exciting venture into ethics. And this week we're talking about the key concepts and framework provided by Dean Newsma's work on alternative and appropriate design in the article you read. Now, we're coming at this from a broad relationship to the other articles we've talked about. So we will be talking about and using the concepts from the ethics reading, deontological and consequentialist, are distinct and separate things, and we'll keep those in mind as we work through this, because in some cases the key concepts here will be easier to relate to them. But we're also adding in a variety of new things and clarifying how different elements from the previous readings work and how they link to our discussion of technology that's centered around Winner and Matheson Gray. Now, Dean Newsma talks about the distinction between alternative and appropriate design, and he uses this historical moment in the 1960s when technology transfer fails. And technology transfer is the attempt to solve problems or to provide benefits or do something or perform a function with a technology in one context, one place, that had been developed and made or used in another place. The classic examples of this we could look to are things like the development of tractors in the United States kept getting larger and larger. I have a picture of a big combine harvester, but combine harvesters are millions of dollars. By the time you make it worthwhile and functional to use a combine harvester, you need giant fields which are uninterrupted, and you need a big investment. They produce a pressure that produces larger farms or makes them more valuable, more reliable, more doable. And it turns out that when we try and sell combine harvesters outside the United States, most of the rest of the world has smaller farms, has broken up farms, has different kinds of farm field management, and combine harvesters don't work in those places as well. So little old farm tractors tend to be a preferred technology. They are more appropriate to those settings, those places. And where we have big conflicts about that are, for example, when we try and change multiple contexts to do it. We burn down the Amazon rainforest to try and make that context more appropriate to combine harvesters and large scale ranching, as opposed to developing a different technology or agricultural process that would be appropriate to that context. Right? We need food. So instead of doing context appropriate design, we break the context. And what this particularly became an issue in the 1960s because after World War II, between 1950 and 1960, a significant amount of effort was put into the planning of development and peace promotion, which involved technology transfer. Because if we have stable people in the world who are not starving, who are not in the middle of fights, we won't have another giant war. The plan was that the dissemination and distribution of technologies would do that, would help people. And it turned out that in many cases, the versions of technologies that were being sent places did not manage to do the job of doing it. And the nature of that conflict between technology transfer points and the context to which the technologies were sent was an ongoing issue. I use this silly example of tractor technologies. It turned out that, for example, the access to repair parts and the overall expense were big issues in transferring giant tractors and combine harvesters to Africa, to India, to Latin America, to the developing world. And so the simple extending of American style agriculture to other places was not a good solution for food insecurity and famine in those places. They were often technologies developed in the United States that were high energy efficiency, but also high cost. They were high production, but they used a lot of technological infrastructure as opposed to labor. And so the variety of things that were possible to deal with in this way in the 1960s was increasing. You had major errors or failures of context appropriateness in transfer of technology related to agriculture, production, development, as well as political technologies of more traditional electoral politics. If everybody is spread out in the countryside, having one voting machine is not a great option. What you want is a lot of cheaper, easily to distribute voting devices. Doesn't matter if they're less secure if you can't get everybody to the city to vote. And so, for instance, one of the things that turns out is modern voting machines for most of the century were too large to carry around in a van, so that people had to figure out ways to, instead of sending big trucks to move voting machines around, people made smaller voting machines or returned to the older fashioned technology of a locked box and a piece of paper. And you'll see images of things like, because we want some form of security on it, using the finger dip in ink so that people cannot do that, rather than other more technologically advanced, technologically complicated, technologically expensive identification technologies. And so it gets very complicated to look at technologies in context. Contexts are made up of culture, technology, infrastructure, all sorts of things. And the people, the place, the things involved are difficult. And so the idea of appropriate design is that when we talk about a technology in context, we're going to look at how well it works within a specific context, how it matches or is appropriate to one situation and context. And we're not going to assume that long durations of time or great distances don't make a difference. If 50 years have gone by, it may be that the context has changed. If you travel 50 miles, 100 miles, 1,000 miles, the context is going to be different. And so the premise of appropriate design is that good design, this is just straight up good engineering, good design, should take into account what the context is. And there is the concept occasionally talked about in STS of the technology fix, which is, for example, the urge to say, we'll just fix a complex problem with the technology. Technology fixes generally are context blind. They are not paying attention to the details of context. They are associated with the idea from technological determinism that if we add a technology, that automatically sort of improves or pushes things forward, which has tended to fail. And my favorite example of this, there's a picture there of the yellow rice and the white rice. That's not a culinary yellow rice. That's what's called golden rice, which was a technology designed to solve curable blindness. It turns out that a lot of people go blind in the developing world, places where famine is a problem, because they don't have enough vitamin A in their diet. Scientists said, oh, we'll just fix that. We're already giving out rice as food aid in most of the world. It's the most common staple to be used as food aid to help people in famine areas. We'll just add vitamin A to it. They plugged in beta carotene, which is a nutritional plant product that includes vitamin A into rice, and it worked great. And then they started sending it places, and it turned out, A, people didn't want the rice to look yellow because yellow was associated with being ill. There were cultural conflicts, but far more importantly, they'd also failed to pay attention to a basic nutritional fact in order for the body to digest, to make beta carotene into vitamin A and vitamin A into physiological metabolic usage to prevent blindness. You needed a certain amount of fat in your diet. Because we were often talking about places which were hot, we didn't tend to add even vegetable oil, but any form of fat to the food aid, which meant that suddenly the golden rice, this beautiful tech fix for a major complex problem, was not useful because they could eat golden rice all day and they wouldn't metabolize the vitamin A. And it's not that technology doesn't have value, right? We could look for ways and specific contexts in which it could fit and be a solution, but by assuming a universal context-free problem and that any technology placed in that would be right, they shot themselves in the foot, sort of. And there's been continued development of it, and there has been occasional useful in specific contexts where things were specific ways. There have been successful uses of the golden rice technology, just like there have been increasingly found new places where advanced agricultural technologies have produced more food and have cut down in some ways on food insecurity and food scarcity issues. So what we're seeing with appropriate technology is that technologies are good or bad, well designed, poorly designed, successful, unsuccessful, in light of context. And in the first set of readings, we actually talked about this as context dependency. All technologies are context dependent. So the thing about that is that while we can get a handle on appropriate design by talking about and thinking about design, engineering, and technology productions as being related to context, we also want to take a step back and think about the concept of alternative design. Now, alternative design is particularly important here because it reminds us that if there is something that is an alternative, it is alternative to something. And so if there are alternative design philosophies, alternative design theories, then there has to be a non-alternative, a dominant or a mainstream one. And in the article, we can sort of see Dr. Nuzma referring to both dominant mainstream technology design, technology development, and engineering, as well as using the term hegemonic design. And hegemonic means dominant, but it actually implies one specific thing that's added. It's not just that it's everywhere, it's the main one. That is, it is the non-alternative, but hegemonic means that there is a pressure to see it as normal, right? That it is hard to question because it is the normal version. In hegemonic design or a hegemonic system, not only has it been developed into and structuring education, textbooks, etc., but you have to have an explanation. You have to be able to justify doing things differently. So, for instance, if you say engineering has tended to produce a ton of stuff based on petroleum, I don't like petroleum, so I'm going to do an alternative design. You actually have to justify moving away from petroleum. And that's the classic example of it where most of synthetic chemistry, which is the majority of all chemistry, except for pharmaceutical and organic chemistry, even that tends to still include pharmaceutical petroleum-based processes, but almost all of synthetic chemistry is related to petroleum. So it's really hard, for example, to move away from that without a specific justification that you need to get away from the use of petroleum. And so we have an alternative chemistry called green chemistry that derives less of the way chemistry works in terms of industrial and synthetic chemistry from petroleum-based products. So an alternative is always visible. We can always see it because we are moving away from, we are no longer accepting or assuming the dominant version, the hegemonic version. And that's particularly important because it allows us to be reflexive and ask questions about the dominant version. In reality, most of us, we don't ask those questions. We're not reflexive and intentional. And then that means that to some degree, we're just not choosing or being decisive in doing stuff a certain way, right? When you say, I'm going to eat this for dinner, if you have no other options, you're not really making a choice. You're not making a decision. You're just doing something. And so it's particularly important to have an awareness of and attention to alternative design philosophies and theories, because that is literally the only way that you can conveniently begin to look at, to parse out, or break down and see what is actually included in the accepted dominant way. Now, we're going to move on from that introduction to what alternative design and appropriate design are as concepts to a discussion of why that's important to this class in the next slide. So, we're going to talk for a minute about some basic definitions and how this relates to ethics. Now, the thing about understanding what you're doing being central to ethics, you have to know what it is, why it is, and where it is to know what kind of outcomes to predict in a consequentialist approach. And have to know why and what you're doing to match them to the appropriateness or the rightness of actions in a deontological approach. You have to understand what you're doing. And that can get significantly complicated. So when we're talking about actually making a decision, we tend to want to be able to do something to simplify it. One way to think of doing that is that you're doing the process that you're doing, the way you're undergoing it is a framework of decision making. You're looking at the context, the situation, you're thinking about what is going on, and you're being aware of those things you've been trained or attentive to awareness of. That means that if you're not paying attention to something, if you think of it as unimportant, it tends to disappear because you have so much else to think about. And that's one of the reasons that this article is so useful is it gives you a set of checklists that allow you to prioritize things or to make decisions about what things to prioritize as opposed to stumbling along. Now, once you're aware of what's going on in the context, once you're thinking about what the situation is, once you know what's involved, then you can think about what your specific obligations are, what your contract is, what your job is, what your commitments are, what your duties are, and those form a limitation space. That is a set of things that you won't do, and then within those limitations, you have options or choices or thoughts that you can decide about. And only after that are you really making a choice. But in order to really understand that stuff, you kind of do need to have an idea of what a duty, an obligation, and a commitment is, because they're not the same thing. Each of them is slightly different. And we're going to return to something we said last week about the nature of professions as a place to start. Every job likely has some obligations involved in it, but a profession is built out of duties. A profession is inclusive of or centers around a specific set of ethical duties derived from the nature of the profession. And for instance, you just can't be a doctor if you intentionally go out of your way to harm people, right? That's not the meaning of doctoring. The nature of being a political officer might be variable depending on where you are, what kind of place it is, but by definition, the job includes performing the duties of the office. Being a whatever kind of profession means performing, being subject to, or expected to do those duties. And the difference between a profession and a job is in some ways, doing a job is about doing a task. You do that job because you do that task. You are not that job. But somebody who is in a profession has a role or an identity defined by that profession to some degree. And for a lot of people, they forget that, much like they forget the duties, but it is central to what it is to be a profession. And that's important because along with that profession, having duties, it has a, a benefit to the person in it, right? It has the definition of that role, which is presumably something you want to do because you're in that profession. But it also, the way we built professions historically is by including both duties and rights to them. Rights have to do with the natural order of a thing, the foundation or the deontological being of the thing also, right? But they allow as opposed to demand. A duty is a demand that arises from the nature of a thing, whereas a right is a permission or an acceptance of something. And you don't have to follow through, right? You could have a right and then choose never to do it. To some degree, you can have a duty and then not follow through with it, but that presents a greater problem because that demand is always there. And so the rights come in very specific ways for professions, right? Human rights, every human has them. Most of the time, we don't question that. But with a profession, you get those rights also. Doctors have the right to prescribe medicines, to do certain things. They're the only person who can stick a knife into somebody and it's not illegal. Engineers can sign off on work by other builders and engineers. They can do an evaluation. They can take on major projects. So there is no place in the United States now where you can build a bridge without an engineer approving it. If you can't get an engineer to sign off on a bridge, you just can't build it. There are certain rights that are protected. They are monopoly rights or special rights that are assigned to the profession. And the reason you make those rights available to those professions is because the people in the profession have accepted the duty, right? The duty of public care, the duty of whatever it is. So what we have to remember about that is that accepted ethics, right? Once you've signed up for it, you're either a cheater or a liar or something, or you have to follow through on it. So once you've licensed as a doctor, once you're licensed as an EMT, once you're licensed as a lawyer or a CPA or an engineer, you have accepted the duties of the profession. And that means that there may be some flexibility in how you do it, but you still have to work with and live up to that duty. And so once you've accepted an ethics, a rule, an obligation, a commitment, duty, those things, once they're accepted, once you've taken them on yourself, they are no longer voluntary. They become involuntary or mandatory. Now, we've talked a minute about what duties are. Duties are deontologically based, or at least we should say deontological duties. Technically, you can use duty in other ways, but a duty that is deontologically based derives from being, the nature of something, from a fundamental belief, and aren't going away unless the nature of the thing changes. Right? So if the world changes dramatically, we might say that it's possible. If you quit a profession, if you can no longer be called an engineer or a doctor, you lose your license, you lose your role, then all of a sudden, you no longer have that duty. And I can give you a silly example is my brother went to law school, got a JD, but he never took on the duty of being a lawyer. So he's not allowed to practice law. He works in public policy, but he's not a lawyer because if he took on the right to give legal advice or charge for legal services, then he had to follow the duties and ethical rules. And that's, by the way, not to say that there aren't plenty of practicing licensed lawyers who do bad things, but they are doing something bad because of that. Because they took on duties that are specified in the profession. So once you are in the profession is ongoing, and therefore the duties are ongoing. They can't be fulfilled, right? You're like, ooh, I did a good job on this project. I've done my helping the world. I no longer have a duty to public welfare as an engineer because I did a good job on that project. That's not the way it works. You do a good job, you've performed public welfare, you saved lives, and then you move on to the next project and you still have an equal amount of a duty to the public good. That doesn't mean you can't earn a living, it doesn't mean other things, but you can't not hold on to that duty. As long as you're in that category of that thing, then you have the duty. And duties and rights are related, right? You can't be denied the rights of the profession as long as the basis, the warrant of the fundamental belief or the category or the type of thing you are has those rights, right? So an engineer, by definition, gets to practice engineering unless they're there's some particular reason why they go to jail or something. And to be honest, even if you went to jail, you would still, you'd have a hard time finding clients, but a licensed engineer in jail would still be guaranteed the right in law to practice engineering. They just would have a hard time finding clients. And so by extension, a right may produce a demand from other people, right? So the people who run the prison, because you have the right to do it, they have to do some accommodation because they also work within a system which respects the rights and the duties of that profession. And the classic example of this is the example of human rights, right? Technically, the human right provides the right, the option, says we must have an option for something, but other people must limit their own behavior, must act in a way that allows the right to be expressed for other people. So nobody can cheat around those rights that are established. And we'll come back to this question of rights later in the class because human rights or other fundamental rights are an important ethical concept that we should keep in mind, right? If something is a right for all people, then you have no allowance. There is no permissible or ethical way to take it away from people. Now, duties are different from obligations. While a duty is general, it's ongoing, it derives from a warrant or a foundational belief or a foundational kind of nature. Obligations are specific. They're a course of action imposed by agreement or demand or requirement. And that specific action can be delayed potentially, but it is something you have to do. It's a requirement. And generally, obligations have an external referent, but they don't necessarily have one that's defining in nature, right? So if you have an obligation, you don't stop being a human being because you broke your word. Now, to some degree, if you break a basic duty of human being, right? If you become a serial killer, the reason that serial killers are not normal humans is because they broke a basic duty not to be crazy and kill people. And so the idea that an obligation is a specific thing, you can succeed at it, you can fail at it, but in the end, you're still the same kind of person, the same kind of thing, whether you were good or bad about fulfilling obligations. They don't have the same connection. It's not a bidirectional effect on their origin, right? So you don't show up to the movies after saying you're going to be there. It doesn't necessarily even make you a bad friend. It certainly doesn't necessarily have a long-term effect. Obligations may make people less reliable if they fail to live up to obligations, but that's an effect, not a change of what and who you are. Commitments are promises or it's sort of a weird thing. We use a word that's a synonym to define something, but commitments are promises that compel someone to follow or avoid a particular course of action, right? And in that sense, it's not the actual action, right? It is the promise or the intention that matters in a commitment. A particular course of action should be directed with sincerity and focused purpose. In some ways, if you make a commitment and then you try really hard, the action is less important, right? You commit to something and you fail at it. The important thing in a commitment is often that you tried. You committed yourself. And so often commitments are self-imposed or accepted as opposed to being based on an external referent like a contract. And they include attention and focus on what you're trying to do, not necessarily on the outcome, the completion. And you have a commitment that you don't have to ask or question that thing again. So the thing about this is that once we start understanding what these are, we can think of them as a priority system. It is always most important that you live up to the important duties. It is slightly less important that you live up to a little obligation, right? It's one thing to not turn in your homework. It's bad to not turn in your homework, but that's the obligation in a minor way. You're not going to no longer be a student, right? There are things that you have a duty to do as a student, theoretically to learn, to pay your tuition because we have monetized education. You have basic duties. But if you just never go to class, it might make you a bad student, but it's not going to take away your student status, right? The duties related to it are about academic honesty. They're about attempting to learn. They're not the little obligations. The little obligations, like doing every piece of homework, are there because you've agreed to do them, but they're also there because the obligations of being a student, the little obligations, they're supposed to be justified by the larger duties and rights of the student. You have a right to learn. Therefore, those obligations should be in service of learning. And inside that larger duty, if you commit to it, if you try harder, you are likely to fulfill your duty better. You are likely to direct your attentions and prioritize your actions more. So we want to keep in mind that when Dean Nuzma talks about these as attentions, he's also suggesting that we can, if we have committed ourselves to doing appropriate good design, if we want to be good engineers, we have to think about what we're committing to. And in particular, by looking at these alternative design theories as things that you can commit to components of, it does a lot of work at making it less overwhelming to try and think of all the context effects, right? So when we go back and think about the nature of good design as it was laid out in Mathis and Gray, they say, look, you're responsible for all of the unintended consequences that arise from changes to the context, changes to the world over time. And that can be a lot. So what kinds of effects, what kinds of changes you commit to paying more attention to, that may be a way to be able to manage it. So a big part of what we're going to suggest in this class is that making conscious, intentional, reflexive, process-based decisions requires you to be able to pay attention to some things. So before we go through all of the different attentions theories in Nuzma's article, we're going to start with three of the key concepts that are actually hardest for people. One is we want to understand the concept of equity or being equitable, because it is important to the idea of socially responsible, socially directing design. And the thing is that much of the time we are familiar with the concept of equality, of equal distribution, and not with the concept of equity, which is often translated as fairness. But the way that this works is that we should remember in the concept of equity, it is not fairness at the beginning of things. It is attempting to get fairness in outcome. So when we talk about fairness, we might be able to go back to that word equality and say, if I give everybody in class $1, that is fair. It is equal. But if everybody in the class doesn't need $1 in the same way, then it's not necessarily equitable. It's not that kind of fair to give everybody $1. If, for instance, one of the students in class hasn't eaten in a few days and a second dollar would allow them to have a decent meal as opposed to a candy bar, I think it's probably more fair. We would recognize it as more fair to give them $2 and then everybody else could have 90 cents. The nature of the distribution in a distribution model either emphasizes fairness in process or fairness in outcome. And equity can be in either process or outcome. The example I just gave of giving dollars to people is about fairness of outcome, right? That if it has a greater effect on people. And so we can have a discussion about equity as being the nature of either or prioritizing either process or outcome. Um, I think they're both valuable, but we're not going to really have that discussion right this moment. What we're going to have instead is just looking at this silly example. When we look at the three kids looking at a sports field, you see that one is taller, one is medium, one is shorter. If we provide an equal technology, if everybody has access to the same thing, different people in context will have different effects. If we want to do an attempt at a different response, a more equitable response will provide a greater support for the short kids so we can see over the fence. Or we can look for an equitable outcome. That is one where both the process and the outcomes seek an improved fairness and improved equity in which everybody has significant benefit. And so the concept of equity or being equitable is center to what we'll talk about in a minute or two as socially responsible design. And I often use the example of you cannot revert back to equality, because if you have that example of the dollar, I use a silly example of somebody who hasn't eaten much lately. You guys probably, you know what being broke is like. In Newark, $1 for a homeless person can mean not freezing to death because it means you can get onto the light rail. And that may sound strange to you, but literally part of what we do when we talk about equity is to recognize, again, context differences. The available possibilities within any given situation change the value and meaning of things. And when we start putting work into thinking about how those value and meaning changes happen, we are paying attention to equity. Now, equity is a really important concept, and it relates to the official, what Newsma links to the concept of social responsibility in the idea of agency. Now, agency can be considered a word for power, but we want to make a specific distinction. Agency is not just power. Power is often defined as the ability to make an outcome, right? To produce an effect. And so while power is generally, whether you're talking about individual or group power, that can it or can't it make that happen? When you talk about power, we tend to make context and complexity less visible. So you say, well, could you have done that for yourself? And the person says, well, I guess I could have. You don't get to the next sentence that says, but if I did that, then I wouldn't have been able to do something else. And so when we switch to using the theory of agency, what we're doing is saying that power plays out with strings attached in context. So agency is situational, and when we talk about agency, we recognize the interactive ability of the subject, that is the person acting, to act only in certain ways, right? And we've talked about enablement and constraint by technologies, but this is the effect of all those technologies, all those systems, other people's actions enable and constrain. They make some outcomes more possible, more likely, less possible, and less likely. And when we talk about agency, we're trying to recognize all those effects that make some outcomes, some pathways more possible. So even though somebody has a desired outcome, they want this to happen, they may not be able to do that, or they may, in order to try and do that, they would have to damage too much or insult too many people or harm somebody else, and therefore they don't actually have the power to do that because those other aspects provide a pressure or an agency of their own. They are acting. That is what agency is. They act to modify the potential outcomes. And so when we talk about agency, we're referring to the ability to act or make an outcome of one sort, but we're not saying that agency is the absolute power. It's the context-based or context-dependent ability to negotiate other aspects of the context within social structure, within other decisions, within whatever is going on, to act and to prevent or to have your actions prevented. And that the discussion of agency when we're talking about social responsibility is a really important aspect because it allows us to begin seeing how both technological design, material elements like what materials things are, how heavy things are, where and how machines are distributed, help to produce different outcomes, right? Because if we're not looking at those as a system of contexts of situations, we might have a tendency to say that, of course, everything is equal, right? Because there are airplanes in the world, everybody has the opportunity to go anywhere, right? That's just true in one sense, right? There is the absolute power to get on an airplane. Anybody can go get on an airplane, except if you don't have money or you're denied access or you don't have a passport or all sorts of other things. And so when you start that process of moving from, well, yes, any human being could get on an airplane, that's a question of power, to why and how some people have more access, more ability to make use of those airplanes than others. That's agency. And then the third idea that we want to get to is that governing mentalities, which are the subject of feminist design, or what we'll talk about as critical design also, governing mentalities are repeated patterns of social thought that form the foundation for other beliefs and evaluations, right? So they're ideas that we hold that are linked to or built in so that other ideas can be present, can be made manageable, can do things. And those governing mentalities tend to be broad assumptions about the world that we don't question. They are what's called naturalized beliefs, right? We don't think of them as things we learned. We just think of them as things that we know about the world. And so the way that we can think about governing mentalities is that they are ways of thinking that we assume and that limit or govern our ability to understand the world. One of those examples would be our ongoing discussion in the class of individuality, right? So when we talk about agency, the language in English to talk about the ability to act is individualized. It's actually hard to talk about how people affect other people's ability to act. So we can talk about collaborative agency. That's what groups do. You get together and you work together, and all of a sudden you can do more. 10 people can lift a car, one person can't, so you have collaborative agency. But most of the time we forget that, for example, nobody works on their own. Right? In a society, everybody's job is dependent on everybody else's. And so all sorts of ways of talking about things don't pay attention to how connected everybody is. And that's a good example of governing mentality, because it's only when you start thinking about networks, about systems, and about how people interact that you start moving away from thinking of everybody as being what we talk about in social sciences as being isolated or atomized individuals. And so in the article, we're looking at feminist design, and the governing mentality that we're talking about is binary gender and presumptions or assumptions about what it means to be a member of a sex or gender. But that's not necessarily the only governing mentality. And in fact, in class in a minute, we'll talk about that feminist design is one example of critical design, where you look at these assumptions about the world and you say, I can play with that, resist it, or change it using design, using engineering. So in Newsom's article, he uses this definition. He says governing mentalities, those widely shared values, norms, and expectations that are important and the most difficult to identify, pervasive, subtle, distributed patterns of thought that underpin social activity and personal interpretation, which is a really hard definition for most people. So, like, literally, we can, as strange as it may sound, we can jump back for a minute to the idea of culture, right? You would not be able to think about what a pencil is if you didn't know that writing was a thing, right? You wouldn't necessarily be able to think about computers if you didn't know that electronic devices were a thing. And so one thing to think about is that when we pay attention to one piece of knowledge, one idea, we're often relying on other things. And in the philosophy of science, this is actually, there's a fancy concept called the Quine-Duhem theory that says that all hypotheses, all thoughts rely on acceptance of other hypotheses, other knowledges. And in order for our thinking to work, we kind of don't pay attention to all those other things we rely on at the same time, right? You say this is what's real in the world. You forget that you're using language and that, for instance, your language is different from somebody else's. So we tend to forget how complicated the world is, and thinking about which governing mentality we want to focus on at one time is one way to think and respond to that. All right, so as we move from my introductory lecture into the what may seem strangely slightly briefer part, where I go through the contents of the article, I want to just reiterate or review that there are two sort of similar words here. One is appropriate and one is alternative. In appropriate technology design, we're considering, we're referencing, we're making sense of how well matched technology is to the context of use, to the position it's in. And at the same time, we're wondering if we can change or improve the appropriateness. That is, how well or how successfully a technology performs within a context. And in one level of the argument that Newsma is making, one level of argument in the literature on appropriate design, all of the attentions from all these different specific focuses in alternative design would be included there. And in that sense, he says it is so common to do inappropriate design that if you pay attention to any part of what appropriate design would look like, it becomes alternative as opposed to the dominant form of design. So if appropriate design is how well things fit the context of use, the place, the time, the moment, the situation that they're participating in creating, alternative design instead says there are dominant ways to engineer that are hegemonic. You are told to think that way. You are, in fact, in some cases punished for breaking away from that. But in that dominant mode, people often don't do a good job of being appropriate. So if you want to do a better job of designing, instead of doing it the dominant way, the common way, what you should be thinking about is how parts of design can be improved in what ways they are appropriate. And by recognizing that it's a failing of much design to do inappropriate design, you're breaking away from or doing an alternative form of design. And that's the idea here. So in that way, we're going to ask that ethical engineers and designers try to do ethical design. That is, try to pay attention to how to live up to their ethical commitments and goals to do good design, better engineering. Hey, so each of the slides is following this will focus on one of the various 5 attentions. And in each case, the attention is the component of context and the central issue that distinguishes dominant design from the alternative. On this slide, introducing all 5 of those, I have a summarized version of what that attention is. That is, for universal design, it's diversity; participatory design, it's disagreement; ecological design, it's uncertainty; feminist design is governing mentalities; socially responsible design, the issue is agency. And in each case, I'm pairing that with an expectation within hegemonic design, that is, what is going on in the dominant system of design that is alternative, that you need an alternative to. So for instance, universal design maximizes attention to the diversity of the human experience and variation in human abilities, and that's very different from the goal of minimized complexity that is central to what's called elegant or streamlined design in hegemonic design. Participatory design, which is looking at disagreement, the negotiation of different politics between different groups, centers on one kind of politics between the designer and the user. And in hegemonic design, where dominant design says we want to keep all the power and decision making with the engineer so they can do their job, that means that there is no negotiation. There isn't really any attention to what the user wants or demands, except where it may limit sales. And so we also mention a version of attention to disagreement that is simpler, called user-centered design, in which we have a different focus. In ecological design, which we're saying it pays real attention to uncertainty, sometimes I refer to that as the management of complexity and risk. We compare that to the hegemonic issue of that specification should be simplified, that design should respond not to everything in a complex situation, but to the key issues that are defined as the requirements. And in the article, Newsma makes a reference to this being a command and control mindset. So you give a specific order, and then you make the situation produce that outcome. It follows the order. And one of the differences would be that instead of saying we're going to do this one thing the way that we're going to do it, we reducing the complexity down to, is that thing being accomplished? We're going to accept a lot more complexity and a lot more uncertainty within ecological design. And in feminist design, which is often the hardest, in the preceding slide, I did mention governmentality and social entraining. The way that we learn about the world makes other kinds of actions possible, ways of understanding the actions. In governing mentalities within feminist and critical designs, whether you're talking about anti-racist design or some other kind of critical design, not feminist design, the goal is to say, no, designers are making the world the way it is, and you can, in fact, choose how to do that. So there's a famous reference to the lawyers and activists who were working to dismantle segregation and Jim Crow laws as social engineers, right? They chose to attempt to make laws, to change technologies. They worked to redesign the world to be less racist, right? Similarly, technologists, designers worked to remove barriers to women's participation in all sorts of activities by redesigning things in such a way that more varieties of people could use them, and it was more legitimate for women to participate in those fields. You actually make it easier to consider gender equality by changing the mechanisms and the infrastructure around people. And it's really easy to see how alternative that is, because most of the time it is absolutely crazy to think about the idea that an engineer is redesigning the social world, the expectations, and the politics of things. And so in general, dominant design argues that things are socially neutral, apolitical, and that it is not the place of engineers to modify the world. And hopefully at this point in the class, after talking about Langdon Winner, after discussing the politics of technology, we know that no matter what you're doing, you're always going to be contributing and modifying the world. And so the argument here is that you can do that if you think the world isn't the way it should be. You can do that intentionally and directly as a better part of engineering. And the final one, socially responsible design, which sometimes is referred to as empowering design, looks at the way that technologies, structures, infrastructures, architecture distribute or allow the use of power. And that power in the form of the concept of agency, that is, the ability to act within limitations or despite or within and because of the kinds of stuff going on. So if everybody has a knife, then that means that you can have food that needs to be cut up. If some people have a knife, then some people get to eat that food and some people don't. And we can look at how the technology is available, the structures, the form of the technology, and the kind of the technology decides which groups of people deserve to have the ability to act, deserve power. And again, much like critical design, feminist design, the hegemonic design system just says it's just not important. It's not the right of the designer to really think through those questions of power. And you shouldn't be talking about that, or you should do it without making it overt. You're not trying to change things. And we don't like that. We want in alternative design to say that, no, if you think that something needs to be done, if you think that a group of people need more power, the ability to make a decision, you can structure the technologies to give different people different power and different decisions. So what you're going to see on the next slides is just a little bit more about each one, trying to explain each of them and trying to explain in general, a specific tip. So for instance, on the general slide here, you'll see there's a tip in each of the side column on the right. Okay, so here's the basic outline of this. In the article, Nuzma describes 5 theories, that is 5 approaches to design. Each one emphasizes or draws forward or centers or prioritizes an aspect of context. And in that sense, an appropriate design would pay attention to all of these because in any given object, in any given artifact, in any given technology, in any situation, all of these aspects are potentially things you can pay attention to. But most of the time, as I said in the earlier lecture, we can't do everything. So the question is, as you prioritize, as you consider what is most important for you, you select to highlight. Not everybody is going to be doing every kind of engineering in the same way that you don't have to be both a computer engineer and an architectural engineer, or if you're doing bridges, you don't have to be concerned with, for example, how to cross an ocean on a boat, different kinds of engineering. Each of these 5 ways to do design emphasizes an aspect of how to do the design work. In universal design, we look at the attention is placed on diversity. That is how different groups of people, kinds of people, different people in different situations need and would be affected differently by different aspects of technology so that no technology is equally good for everybody. It does not serve everybody equally, and that means the more kinds of people we can consider how it will affect, exclude, or enact with, that means that we will potentially be able to produce a larger group of people that are treated correctly by that technology. And universal design is often related to, for example, accessible design, where we think of specific people who have barriers or who might be denied use of or access to a technology, and we make a modification to the technology to give that one or various kind of person access. And what we'd want to note about that is that in diversity, we're not just talking about one person. We're not talking about one kind of person. We're not saying for colorblind people, we're going to have an element of not using colors in this design so that people can still see it, nor are we just going to add the question of how do we add a ramp so that somebody who has a wheelchair can do it. We're going to ask and say that the design is actually better for everybody. It's not only better for somebody in a wheelchair, but a design is fundamentally going to be a better design for everybody if we can expand that envisioning of who people are, recognizing that as an aspirational goal, right, moving towards a future condition, not necessarily 100% achievable now, we will try to include all those differentiations and diverse forms of human life. And that's not something that's very simple. Accessible design is much, much easier because then you're just saying, here is one known problem, I'll fix it, as opposed to trying to create a better technology by including a real understanding of the width or breadth of human diversity. And in looking at that diversity, we are able to recognize that there are issues in the hegemonic design. Sorry, I got cut off, and we'll have two little sound buttons on this one. I'll try and put a note there. But in looking at universal design, the issue is that we can recognize that in hegemonic or dominant design, most of the time you don't get asked to think about everybody. You're asked to think about a very small consumer audience or a very small group of people who are likely users, and you may not even have good evidence or reason to determine who that is. And so often in dominant design, we see, as opposed to the diversity of human experience and human variation, we see that we're encouraged to look at a minimized complexity. And the presumed universality of use and function within that is a real problem because, for instance, it means that you only produce a technology that is to do one thing. And you may not be responding to the right needs or the variety of needs available. And similarly, the reliance on the perspective of the engineer as if who we are, who our bosses are in many cases, was representative of all the needs of everybody out there, all of the abilities of everybody out there, certainly does not mean that we're actually going to do the right thing. Because if we're doing something based on what our boss and we say is the right thing, there may be many other people whose use of that technology will be impossible or who cannot get what they need out of it. And one of the things that people used to be taught is a thing called the mirror technique. And this is, you're like, what color should I make my prototype? And your professor would say something ridiculous like, well, think about what color you would want it to be, where you use yourself as a sample of what people want or need. And one of the things that this tends to do, and while we don't tend to call it the mirror technique anymore, we still tend to be taught to design this way. The issue becomes fairly straightforward that the use of the mirror technique means that if we have a lot of, for example, if I as a professor, I'm a middle-aged white guy, if I am not good at paying attention to what the needs of, a working class 20-year-old person of color is or what women need, then I will not represent that in the design of the class, in the design of the object or artifact or technology that I'm doing. And so by using yourself as the example or exemplar in the mirror technique, you tend to replicate and deny access to technologies that would be useful to more diverse populations. In participatory design, we're really talking about who has the choice of what is produced. And most of the time in dominant design, the designer makes something and then the only choice a user has is whether they buy it. Sometimes they use it without buying it, but whether they make use of it. They can opt out or not. And participatory design says, well, what if the intelligence of democracy, the variation of ideas out there, would allow other people to have good ideas about what design to use, what should be built, how it should be built, beyond those people who are professional designers. So in participatory design, you bring possible users into the design decision, and you're not only giving them a position to be a resource to the designer. You're saying that in order for their input to be really taken seriously, we have to listen to them. They are participants in the design process. So one of the distinctions that we'll see between user-centered design, in which the project starts, the designer comes up with something and wants feedback, and the user is then providing information to the designer so they may make the decision. That's a little different. In participatory design, you may go back and forth iteratively, bouncing ideas back and forth, trying again and again between the user and the designer. But part of what you're doing is breaking down what Winner and Mumford in the previous reading would talk about as the authoritarian tendency to refuse the modification of the technology to the user. If the users all agree, or if they start to agree, or if some of them say that this technology needs to be different, you don't close the design process and leave them out. No matter how happy the designer as a professional is, unless the other members of the participant team are brought in and satisfied, we're not done with the design. So in participatory design, the attention is on disagreements, right? If we have different people demanding different things, different people who have different levels of power, different people who have approaches to what should be done, they must be negotiated. And in last week's exercising class, part of what we were doing is talking about how do you negotiate between differences. You saw a tiny bit of how that worked, but now in a design position, you're actually inviting those sort of conflicts in as a way to produce more ideas. And one of the things about this that becomes important to the long-term efficacy of participant design is that in the case of participant design, we actually often can find that elements of design that are significant, they are useful for people, they add to the quality of the design, those are often made visible, understandable by the professional designers because of commentary by the non-professionals, by the users. The classic example of this is that in the process of designing the original iPod, Apple engineers had been pretty certain that they wanted to use universal design for the spinning dial control feature. When they started to use a design firm was brought in and they used participatory design, they said, no, this is terrible. Like, it doesn't work with the file system you use. And they had to go back and forth for a long time before it turned out that the problem wasn't this really well-designed, innovative control system with a dial. It was the file system, and that what people really wanted, if they were going to make full use of this dial control system, as opposed to buttons, as opposed to a traditional file structure, was to develop sort of lists of music you could scroll through and not use folders. And they said, that's fine, we'll figure out a way to do that. And in the end, the feedback of the participant designers ended up producing a new name for something we used to call mixtapes. Now we call them playlists, and they've become a significant form of how we think about music, far more than an album or a folder. And that sharing of power does not mean that you are giving anything up, because you are able to produce a better outcome. And so by sharing some of that power, as opposed to in user-centered design, where in user-centered design, you don't want to share power, you just want to get information. The tip that I would recommend is think about a +1. That is a rule of +1, or an always asking +1. When you are on your own, when you're in a group, always seek feedback from somebody else, right? That you can get somebody to read over your paper, somebody to listen to your song, whatever you're designing. If you only satisfy yourself, you don't know if it'll make sense to somebody else. Bring at least somebody else in and give them the respect to actually listen to what they say. And that tends to mean a decrease in your power, giving up something. And it's a vulnerability, but it is a useful design technique. So, in ecological design, whether we think about it as decrease in complexity or increase in complexity, increase in risk or the management of uncertainty, um, one of the central things is that most forms of design in the command and control model literally say we are going to do X. And the the classic example that I've spoken to Dr. Newsma about that we might talk about in class is, for example, how do you keep water from flooding a city? And the use of levees or basically a wall, a dam around the city is the classic example. You say, we don't want water here. What is the single best way to keep the water out? We put a wall up, done. And the argument is that there is a great degree of certainty and a simplification of what kinds of risks and what kinds of management of complexity you're using there. And a lot of the time, that means that you're ignoring other aspects of the environmental system. But most importantly, when you move from that simplified model to an ecological model, you're remembering something important. And that is, in ecology, this is not about being green or being environmentally friendly. Ecology is looking at how all of the various components in a system interact. So you can have a media ecology, you can have an environmental ecology, you can have a financial ecology. When you look at all of the components, and it does mean that you add complexity. You take some of the uncertainty on because you don't know everything in a system. And that means that you acknowledge that there is a degree to which you will never have the certainty that a command and control model of absolute simplification will do. And in some cases in ecological design, as we look at the models of system effects, system inclusions, we do look to nature. So, for instance, it turns out that there are a whole lot of ways that natural systems respond to flooding, prevent the worst effects of flooding, but very rarely do natural systems just build up a big wall. And one of the things that that means is that you can have different responses. So while the picture on the slide of bottom left, there's a shot of the levees near uh, the city of New Orleans in Louisiana, and famously they failed during the Katrina hurricane. And we're going to see failures of levees and dams and other traditional forms of command and control structure because the storms that we get now are worse than the storms that we had when those were built. And by comparison, you look at the pictures next to that, that is a floating neighborhood in I want to say Rotterdam, but it might have been Amsterdam, where they said, look, we have every possible thing, including levees, to keep some floods from happening, but you don't design based on the hope, right? You design based on the reality that flooding may happen, and then you ask, how do we limit the risks, limit the effects of that complex interaction? And so in parts of Rotterdam and Amsterdam, you're not allowed to build new buildings on ground. You build new buildings on these platforms of concrete that float, and that means that even if there's flooding, the buildings are protected from the worst damage of the flooding by floating up above the rising water level. And similarly, the Netherlands, often called the Low Country, where Amsterdam and Rotterdam are, have traditionally had to reclaim land from swamp. The picture of the tulips growing is a classic example of this. This is a plain in the Netherlands, which would be swampy, but they build canals to drain it, and then to encourage water out of the ground to drain it, they build these windmills, which actually pump water out of the ground and into the canals. And what happens with that is that if it floods, the damage isn't lasting because you've thought about not only how to prevent the flood, but how to reduce the damage of the flood afterwards. And we can look at things like the development of climate projects or other kinds of environmental issues, but overall, The modification, the movement in this case would be away from simplification, from design control and command and control to more complex systems thinking. That's the core of ecological design in the alternative model. And as a tip, one of the things to think of is another version of the rule of plus one, right? You think this is what I'm trying to do. This is the most direct way to do it. Well, take one level of complexity. And one way to think about that is with models of efficiency. One of the places where ecological design has made real inroads or real suggestions that have even been taken up in some parts of dominant design is with things like the issue of efficiency, right? Because we generally have a model of efficiency, one input, one output measured. Take the example of miles per gallon, right? You had an issue, a car is defined by the miles per gallon it gets. You want to be able to go farther on less gasoline, and that should solve everything. Later, people point out that in some cases, the increased efficiency actually meant that the engine was producing more emissions, more smog, more pollution. So we look and we add an eco-efficiency model. That's a classic example of a plus one thinking. We want input, output, and we'll add another output. How do we minimize the amount of pollution? Now, that's one single additional issue. Now, you can go farther along that and have more complicated and more satisfactory models of efficiency, multiple inputs, multiple outputs, things like the model of the what's called the production life cycle model of efficiency, where instead of looking at just in use, you'd look at where the materials to produce it come from, the steps in manufacture, the steps in distribution, the moment in use, and then what happens to the car. So for instance, yeah, it might be great to have a Tesla while you're driving it, but in most cases, driving a Tesla is actually environmentally incredibly harmful because the materials to make a Tesla come from so far over the world, have to be so thoroughly and high energy use in manufacture that they are actually worse. You could drive a car from the 1950s for the last 60 years, 70 years, and you'd still have a lower energy usage driving that car, including the manufacturer of that car, because most cars were made relatively locally out of relatively limited environmental impact materials, right? It takes some energy to smelt, to purify, and then to use metal. But plain steel, which was the majority of what you built a car out of then, didn't actually take that much environmental harm to produce. You needed coal. Coal isn't great, as opposed to the 70 steps to make a nickel foam battery in a modern Tesla. And similarly, the life cycle is longer because we expected cars designed in the 1950s to last for 20, 30 years. The average expected life cycle of lifespan of a Tesla is under 10. And when you throw that battery away, if we don't recycle it, which is high energy use, that battery becomes basically a ball of poison or a fire and then poison. And so there are all these other problems. And so as you expand out what the model of attention or efficiency is, we get a much, much more complicated but much more satisfactory way of looking at it. Critical design theories literally argue that the objects, structures, infrastructure, architecture, stuff around us reinforces the kind of thinking and the kind of people we are. And as we look around, we are pressured by the stuff around us to think and be certain ways. And if you loved the way that everything is right now, that's cool. Right? Keep it that way. Don't think about it. And that's often how dominant design says to do it. Like, it's not your job, right? Don't think about those long-term social effects. Don't think about changing it. And I don't think that's the right way to do it, right? Even as a non-critical designer, there are going to be things in the world that you want to intentionally modify. And the moment you're intentionally trying to change the social world, the law, the way people interact, you're doing critical design. Now, the most famous form of critical design is feminist or gendered design. And, there's also anti-racist design, there is anti-poverty design, there's redevelopment or anti-colonial design. But we're going to focus today primarily on feminist design as an example. And one of the ways to think about it is we're restructuring, we're reinforcing the idea of a gender binary, male and female, in simplified singular forms by having coded clothing, by having bathroom door stalls, by having a different price for different kinds of deodorant, by having cookbooks aimed at women, cookbooks aimed at men, by thinking about things in different ways, by producing pockets so you have to wear a purse because women are supposed to wear purses, by having a different size phone that then means that different people have an easy access to it, by how we design cars, right? There's a bias against women as not good drivers, but one of the reasons for that is that almost all cars are designed for an expected driver's height of over 5'8". And that means that it's not just women who are disadvantaged because of that. Old people are, and people from places who have lower nutritional values and therefore lower lifetime height, because if you eat more and eat better as a kid, you tend to grow taller. There are all sorts of groups besides women who are actually put at a disadvantage for how well they drive. It's one of the many factors that makes teenagers less likely to be safe drivers, but we still design cars based on that. The ability to see over and appropriately have visibility around the car past the dashboard is literally a design feature that one could change. One of the reasons that Japanese cars started to become so popular in the 1970s and early 80s in the United States is that traditional cars in the United States were built largely expecting men. They were harder physically to drive for people who have less upper body strength, and they were much harder to see out of. In doing a design for cars that was more appropriate, for example, for a dense city in Tokyo, presuming smaller and less physically strong drivers as the norm. They're no harder to drive if you're stronger, and in general they were not harder to drive if you're bigger, but they were less harmed if you were or harmful or less difficult if you were smaller. And so thinking about how you reinforce and structure the available kinds of politics in the world is the center of critical design. Um, I'm actually going to spill into the next slide with this, but the goal then is to think in terms of changing the governing mentalities. That is, questioning the assumptions that we respond to and the replication of those assumptions that makes it hard for us to change how we think. In dominant design, we are supposed to rely on those assumptions, and I don't think that's a great way of doing it because we might want to revise those assumptions. One of the simple tips you can do with this is to recognize that everybody is biased. Everybody in all sorts of ways. And then your job as an engineer is to question that bias and minimize how it gets built into things, right? Not just your personal beliefs, but those biases that are common in your culture. Just ask, are there differences between men and women, and why would that matter, right? Couldn't you make a technology that it didn't matter for? Because if you can, then why would you replicate a belief about men and women in the device? So you question the technological and social assumptions so that you can try and produce something that gives you a different or better option in the world the technology produces. Newsma mentions the example of the gendered microwave. And one of the things that's weird about this is that often people have absolutely no idea what I'm talking about. And part of that is that many of you don't cook, or if you do, you don't really think about it. But when we first started selling microwaves, they tried to sell microwave ovens to women, largely in the United States and Western Europe, and said, look, it'll cook faster. And a few people tried them. But the thing is, the assumption was that there was no knowledge, no skill involved in cooking. And the idea that it would be faster for people to completely relearn how to cook using a new technology just didn't work. And they were not popular, they were not widely used. Because if you asked people who often, in many cases, spent a lifetime learning how to use other cooking methods, then that's fine. At the same time, during that period, you had an increasing participation of women in the workforce, and that meant that more men were being asked to feed themselves because they were often, problematically, women were often not able to fulfill an expectation that they do all the cooking. That was unfair in the first place. But all of a sudden, you had men who did not want to learn how to cook, were unwilling to, and the opportunity appeared to remarket microwaves. So instead of being a microwave oven that was for cooking, you begin to see microwaves reappear as something for nuking, zapping, reheating, preparing prepared foods, but not cooking. And it was a device to allow men to hold on to a traditional gendered divide in who had cooking skills and knowledge. And even to this day, it still centrally focuses within our idea of what a microwave is for, that it is not cooking. Right? It's one thing to say you microwave some popcorn or you maybe heat some water up, but if I said I can cook a 3-course meal of, a vegetable and a dessert and I made a pot roast all in my microwave, it would sound very strange, in part because it's not an overlapping skill set. And we've never had the kind of structure that does that. But what ends up happening with the microwave is that by both allowing men not to learn to cook and also marginalizing and sort of insulting that which is made with the microwave, we end up producing a technology that very much reinforces that women should do the cooking. And we can talk more about that example in class, but that's the example of the microwave. So if agency is about the distribution of ability to act, then the question is who should have the ability to act? And should everybody have more abilities, more right to act, more capacity, and which capacities or abilities to act they have? And I'm using pictures here of the appropriation of, long since past, the appropriation of pneumatic suspension systems, which were originally designed for off-road vehicles and then become these very different usages. Well, the question is, does the availability of that technology, should it be used by different people in different ways, or should you limit it? Right? Having public spaces that have plenty of space to sit down, being able to lay down, not being able to lay down is a central issue in the debate over what's called hostile architecture and hostile public spaces that is used to decide who can use space in public places in what ways. And in a wide variety of examples, the question of how you build or produce agency with technologies becomes central to design. In socially responsible design, the assumption is that we want to be both careful about directing agency in equitable ways, that means producing greater fairness, but also by structuring and producing enablements and constraints in the technologies, we produce the ability to act or the inability to act, and in doing so, we shape political participation in all sorts of things. Now, traditional user-designer divide in the dominant engineering system, in the dominant design system, presumes that users should not be designers, No power to do that is appropriate. And it also presumes that the best way to determine who should have the ability to do something is the person who can buy it. That is the consumerist model. If you can buy it, you should have the ability to do it. If you can't buy it, then you don't matter. And so market neutrality being the basis for anybody who isn't the purchaser of a product is a really questionable way if you're talking about the ability to do something that is important for everybody. For example, participating in democracy requires information. You need to be educated on something. So it is pretty problematic that most of the best information sources cost money and are not easily accessible. But the dominant design idea is that you're not selling democracy. You're not making the ability to participate in society. You're not producing agency. You're producing a product, and that product is for those who buy it. So when we talk in class, sometimes I use the example of a dollar, right? That a product is sort of a dollar bill, and we don't really care about the difference in who gets the dollar, right? You have a dollar bill, the dollar bill is all the same. And one of the things I always point out is that to get onto the public transportation system in Chicago is basically a dollar. And in Chicago, it's often cold enough in the winter that you can die of exposure, which means that there really are times in some places and some times where a dollar bill is the difference between life and death. So to say that a dollar is just a dollar and you're not changing who has abilities, who has agency, who has the capacity to act within limitations, is just ridiculous. So dominant design argues that those issues in general are not the important thing for designers to take attention to. And I will argue that NUSMA and socially responsible design from an ethical point of view are absolutely right. We have to pay attention to agency in all contexts. And the tip here would be that politics and power can be intentionally designed components, right? In fact, one of the things that Winner will suggest in that article you read is that no matter what you're doing, you're always producing winners and losers. And one of the central mechanisms for that is the ability to act, the enablement that a technology produces is going to be the deciding factor between those winners and losers. And so you're always doing this. You're always deciding where the agency will be produced. All right, that's the basic outline. That's the basic argument. Alternative designs focus on these things. Dominant design don't. We can talk about examples in class of all these things. Each of us who will be a designer, whether that's writing mystery novels or drawing comic books, whether it's being the architect of houses, whether it's being the engineer of the next great consumer electronic product, any kind of designer. If you are building bridges or you're building a small device to carry in your pocket, each of us who will be a designer is responsible for our designs. And in order to be responsible, we have to be trying to do a good job, that we have to be trying to be intentional. And the best way to do that is to recognize what you're committed to and to recognize you're not necessarily going to do everything right. So develop a priority system which says if you think that as a designer, yeah, you have to live up to the core engineering guidelines. Yeah, you kind of have to make your boss happy. But if you think climate change is a problem, climate change is a priority. If you think racism is a problem, racism needs to be a priority. And the way you respond to that is to look at how you can intervene and produce an outcome that is ethical according to that commitment and priority. Even more than needing to know what the client is saying to our boss, even more than having a specific skill, because you can go and look things up, you can go and develop skills. You have to develop the skills to meet a goal, right? You're not going to learn how to do something because it's not important to you. You select the clients who you can do work that you can be proud of. You select the boss sometimes because it's the only boss you're able to get, but you select your boss because they're not going to make you do something you think is fundamentally evil. You're going to pick jobs and projects that are aligned with those goals. Because you shouldn't be doing things that don't meet your goals, your priorities, even as an engineer, even when your obligation is to the profession, the freedom you have, the agency you have is to do good engineering and being a good engineer on projects where your aims, intentions, and purposes matter. Okay, last summary. What does it all mean? Right, here's the thing. Most of the time when people do design, they're not paying attention. You are getting a list of specifications and you're producing something for sale to a product, to a consumer. And the reality is that if you only pay attention to that stuff, you lose almost everything that makes an object, an artifact, a technology really excellent in even one context, let alone many. And so if we want to do appropriate design, we really need to commit to doing good design. And one of the amazing things about engineering is with very little attention and commitment, you can do your job, but you're not going to do your job as well as if you make specific commitments to specific attentions, right? Decide what is important to you, and you'll find that you actually are able to move through the process and do that. Thanks, everybody. The reading for next week are a pair of articles that are talking about choice and mental models. And among other things, we're going to have a supplementary set of discussions of choice in the class lecture next week. But the articles propose inventing or improving technologies requires us to think about what models we're using. And they use the example of self-driving cars, and they also use the example of the trolley problem, which is a classic ethical um, thought experiment. But they both consider the current discussion of both the thought experiment and the development of self-driving cars to be simplified. And in different ways, each article is talking about the need to make a more complex system to think with. And at their core, we're not as interested in whether they answer the question of how to design electric cars or self-driving cars or how to respond to risks in public transportation. What we're particularly interested in is how they point us towards thinking about whether or not mental models, heuristics, and the kinds of thought experiments that teach us how to think are teaching us the right lessons. So in Rennick and Robinson, they're actually talking about the failures of the thought experiment itself in directing generations potentially of ethicists to be asking the wrong question. And interestingly, in recent years, this has made a joke on the television show, television series the Good Place, in which an ethicist on the show refers to this, and it's demonstrated how absurd the thought experiment really is. But what we have to remember is that the thought experiment is still how people are, it's a tool that's still how people are taught to think about ethics. And so we're going to be talking next week about that. We're additionally going to be talking about the nature of choice and the problem that all of us, whether you're growing up in Mexico or the United States or China, to one degree or another, we're taught to think in terms of that individualization that we saw in the Matheson Gray article. We're taught to think in terms of ourselves alone. And that builds up what's sometimes called the model of sovereign choice, where we think of every choice as separated. And what we want to do is stop thinking that way, that in fact choices connect over time, they connect between people, and it is much easier to come up with good answers to complex situations if we don't think about everything as separated.